Good afternoon from the sunny Copenhagen. Welcome to the webinar, Are Small Buildings Always Smart? Lessons Learned from Real-Life Stories, hosted by the Copenhagen Center on Energy Efficiency. My name is Valeria, and I'm the research assistant at the Copenhagen Center, and I'm supporting the activities related to energy efficiency webinars. A couple of things before we move to the main content of our webinar. This webinar is going to be of about 90 minutes long, including time for the Q&A at the end. In case you cannot stay until the end or want to get back to our interesting presentations, all the materials and recording of the whole webinar will be available online in few days on the Copenhagen Center Knowledge Management System. And we have many other webinars and information there. Have a look. I'll give you in a few minutes. A few things about the Copenhagen Center. The center conducts research and advisory activities in the field of energy efficiency and serves as energy efficiency hub for the Sustainable Energy for All initiative. The center has an established network of global, regional, and national partners with a broad range of stakeholders to help accelerate the implementation of energy efficiency activities. On a regular basis, the Copenhagen Center is conducting webinars. All materials, including recordings and presentations from previous webinars, can be found on the Copenhagen Center Knowledge Management System under the e-learning section. The material of today's webinar will be uploaded shortly. I would like to briefly introduce the speakers of today's webinar. Kasper Furu Nielsen is a consultant at the Danish Technological Institute. Babette Peulicke Slott is an energy anthropologist at the Danish Technological Institute, and Vitaliy Bekker is a guest researcher at the Copenhagen Center on Energy Efficiency. Finally, I would like to inform you that you can send us your questions during the presentations, and we will do our best to answer as many as we can at the end. Please do not forget to mention the name of the panelist that the question is for. Before starting with Kasper's presentation, we are launching a poll here. As this is going to be an interactive webinar, we would like to have your attention and answers to the 3 polls which will appear throughout this webinar. The results will be live and I will present them to you quickly after. For each question, you'll have approximately 30 seconds to answer. So here we go. How would you estimate the importance of users' behavior in relation to building performance in smart buildings? Please select one option: not important, important, very important, or you don't know. Thank you very much for participating to this poll. Now we can see the results. 33% of you answered that it's important, and 67% of you answered that it's very important. So now we can start with Kasper's presentation.
Thank you, Valeria. My presentation is gonna be about the technical perspective. It's an approach from the northern climate, since we're gonna show some cases from Denmark. My presentation will give you a quick overview of the main technical parameters of impact in relation to the interaction between the users and the technology. First off, I will start with the design phase. This is just a simple overview of what we think should be considered of main focus when we talk about the thermal indoor environment. And to begin with, I will just take some outtakes from the facade, saying that the window and wall ratio is important, as well as the insulation level. Whether you are going to use internal or external solar shading or not use solar shading at all, and as well in which direction your office is orientated. These next slides are as well another selection of important parameters in the design phase. The next is the ventilation. I specified 3 types of ventilation: the mechanical balanced ventilation with heat recovery, the natural ventilation from windows, window openings, etc. There's no heat recovery. And then the more new way of doing it is the hybrid ventilation with heat recovery. Last but not least, it's very important what you assume about your heat loads. Here I specified occupants, equipment, and lighting. And I'm going to get back to that, why it's so important to have the right assumptions for later on. The operation phase is when the building has been built, and this is where you're going to see the differences between what you designed and assumed in your design phase and what is actually happening in the building. Here it's very important to know that things can happen in the building that you couldn't know in your design phase, and therefore your assumptions can be more or less accurate. Regarding the facade, it's very important to know how it's possible to operate the internal or external solar shading. Occupants that can manually overtake the solar shading can make a huge impact on the designed assumptions. On the ventilation, there can as well be seen differences between what you measure your inlet temperature to be in the room and what you measure it to be at the ventilation unit. This is important to, in some cases, follow up on if you can see that the room temperature remains maybe 1 or 2 degrees higher than what you would expect. Furthermore, people can take over and make their own adjustments to the inlets. This, as an example, could be that they put tape on the inlet to reduce the draft rate, or they could as well adjust the direction of the inlet air to move in a different direction than what you have assumed in your calculations in the design phase. As well, with the natural ventilation, it can be very tricky and difficult to know what people are going to do when the building is being operated. You could either have the possibility for window openings or not have any window openings, and without window openings, of course, it's easier to have your assumptions, but that would make it way more depending on your mechanical ventilation. As well, with the heat loads, you're making assumptions about the occupants and thereby as well the equipment. This can change over time, maybe even at the beginning of the operation phase, and thereby it has a huge impact on the indoor environment. This webinar is about if smart buildings are as smart as we think they are. And hereby we also state that maybe a smart building is a highly advanced technical building. But is that actually equal to a smart building? I'm going to give a couple of examples of 3 levels of technical solutions, and hereby discuss what is good about it and what can actually change from the assumptions you have. Furthermore, I think that technical components must be integrated on the same platform to work energy efficiently, and user behavior must be understood in the relation to the usage of the building. Thereby said that depending on whether the building is used for households or offices or other usages, it's important to understand that the occupants in the building might behave differently. I'm going to start out with what I called the simple technical solution. This is maybe the, at least in Denmark, the old-fashioned way where you manually control most of it. you could either have natural ventilation or mechanical ventilation. But besides from that, you control manually the thermostat on the radiator, the solar shading if it's even there, and you can expect that there is no cooling to the ventilation. This way, it's very depending on the user, and if the user is actually controlling it or not. This can both be a good way to do it, but it can as well be a bad way to do it. What is really important here is that the user need to understand how, for instance, the thermostat is working and what the solar shading is actually helping with in terms of the indoor environment. And it's very important as well to be aware that if the room is already overheated, if you have no mechanical cooling, it can be very, very difficult, if not impossible, to cool your room down to a more comfortable temperature the same day. Moving on to what I call the moderate technical solution. Here is more like a present solution in Denmark. This is the typical way to build, where you have central cooling coils in the ventilation system. You're using mechanical balanced ventilation, and you can either have manually operated solar shading as well as radiator thermostats. Depending on how much the user can interfere with the radiator and the solar shading, and maybe as well the window openings, the assumptions here can be very different from what you would experience in the building. As well, this is a way to operate on what I call a section level. This is not on a room level where every single user can change and optimize to its most comfortable indoor environment. This is maybe a way to control it in a section facing south and north or something like that. It's very common in Denmark, and it's a good way to control the indoor environment and be able to reduce the temperature during summer. And it's as well a way to take some of the responsibility from the user, but it can also be of great discussion if many of the users are uncomfortable in that indoor environment. The last technical solution is what I call the advanced technical solution. This is maybe what we would say is the smart building. On the photo, I showed a smartphone where you can control your indoor environment. This could be one way to do it. Another could be from the computer or another central placed screen in the room. This is operated on room level, where every single room or occupant can individually control the cooling, can control the solar shading, and control the radiator thermostats. This is basically done by selecting what room temperature you want, and maybe the light level, and what is maybe not explained so much in this type of technical solution is what the user is actually controlling, and maybe as well what the user is not controlling. Because what we often see is that they want to control the solar shading. So when the sun is shining, they still want to look out their windows, have the good view. But what they do is actually letting in a lot of heat from the sun. And then when it gets to the afternoon, where the room is so warm that even with the advanced technical solution, it's very difficult to cool down the room again. The user has already interfered so much with the controls that the indoor environment is insufficient. This is going to be spoken more about by Babette in her presentation. So hopefully this gives you an idea of what her perspective is from her point of view. This is what we see as a technical part. Thank you.
Thank you very much, Kasper. And now we can start with the second poll of the day. So, overall, how technical is your work? Is it a simple, moderate, advanced, or work, or you don't know? Thank you. Thank you very much for your answers. So we can see that the 15% of you answer that the work is simply technical, 31% that is moderately technical, 50% advanced, and the 4% of you don't know. Thank you very much for your answers. And now we can start again with another presentation from Babette.
Yes, thank you, Valeria. And thank you so much for attending, all of you. I will be discussing how user behavior is crucial for smart operation of buildings. I will be talking from a perspective of energy anthropology. And energy anthropology is about the encounter between people and technology. So it is anthropology, as you might know it, like the knowledge of why and how people behave the way they do. But this is very specified in the perspective of energy efficiency, energy flexibility, and also indoor environment. So yeah, that's what I will be trying to cover today. First, worldwide we experience this phenomenon called the performance gap, and you might have experience with it as well. It's this notion of when there's a discrepancy between expectation and actual performance of a building, and that goes both for indoor environment and for the energy consumption. We also have something called rebound effect, which is kind of in the same field, and it's a huge issue. Even though we get better and better to doing construction and making better technologies and better buildings, we still have this recurring challenge of performance gap. They don't perform the way we expect them to do. This issue cannot only be explained with the calculations. It has something to do with behavior as well, quite a lot of it actually. So the notion you have to remember before we go into all these cases I have with me today is that you can't really avoid behavior no matter what type of building you have and how advanced the technology is. Either, if you're talking about single family households or it's LEED certified smart buildings, no matter what type of building you have, occupant behavior directly influences energy consumption and indoor environment. And that's something we need to be better to keep in mind when we work with these issues and try to energy optimize and make better technology. So in order to illustrate that, I have some cases with me today. The first two are about identifying non-technical behavior-related barriers for smart solutions. One is for a university building, another is for daycare institutions. The third one is a bit different. That's a project we are working on right now, a more extensive study on these issues, and that's about smart interaction between building and users. But let's start with the first one. That one is from a university building. The project is about data-driven building management of energy-efficient buildings. So this one is specifically about these very advanced technological solutions that Kasper was talking about on his different levels. The project is about decreasing this performance gap because we can see the more advanced a building you have and the more energy efficient you tend to make it and try to make it, the higher performance gap we have. So it's something we really need to be able to fix because we're trying to make more and more of these kind of buildings. This specific building was newly constructed and smart, a lot of high-tech smart solutions. It meets the requirements for 2020 and it's actually performance tested. So it's, we have not a lot of knowledge about this building, and it's it was actually performing very well, but one thing kind of stood out. One of the smart solutions they chose for this building was to connect the ventilation heating system and also whether there would be electricity in the outlets or not, to the booking system. And that's actually a rather clever idea. Why would you want to ventilate and heat and all these things if the room is not used? So that's why they connected these things, so it would only be working when the rooms were booked. Unfortunately, they could see that there would be extremely high levels of CO2 in these different rooms, and they couldn't really figure out why. So we made a study about that. What we saw is that this is a university building, so it's made for teaching. It has classrooms and then more like study rooms designed as open space offices, kind of. And the thing is, at this specific university, people were working in groups. So they didn't really like the atmosphere of sitting a lot of groups together in the same room. So when actually using the booking system, they would prefer to book in different buildings so that they could have their own space for doing group work instead of sitting a lot of people together and discussing. So this building would more be like the second choice, and you would show up there on the day if you didn't find a room for yourself in a different building. So with this kind of behavior, that solution is just actually not smart at all. Even though the intention was good, it didn't work out with the actual behavior of the building. So instead, in a building with a culture like this, it would make sense to base it on CO2 sensors instead. You could also try to make a behavior change, but that would also require that you change the entire way that university works with pedagogical principles, and I think that would be overestimating it. But actually, just changing the system to CO2 sensors would make a lot of sense in this specific way of using the building. Another thing that would make sense at this university was to kind of correlate the booking system and the CO2 levels in order to see how are the square meters actually used, because they have a very they have to have a very rigid system where they make the plan at the start of the year. But they know that when you are a couple months in the semester, a lot of people will stop attending. So why would you have if maybe 40 people sitting in a room to 80 or whatever it could be? So maybe if you were able to use that data and correlate it, you could see if maybe you could have a more dynamic use of the building and a bit more flexible use of the square meters. Yes, so that was one example. Another thing from this this project was very interesting about operation managers, and this is something we see across other projects as well. I have this quote here: IoT, it's the future. A lot is going to happen in that field. I'm dreading it. And that's quite interesting, that quote, because there's a lot of buzz and hype about IoT, and we need to have more technology, it needs to be intelligent and all this. And then we have the people on the ground who are actually dreading it. And to begin with, it seems maybe a bit strange, but it actually makes a lot of sense when you start talking to these people actually operating the buildings. The idea of putting a lot of technology into a building is often that you try to cut down the man hours, and it's supposed to just control itself, and it will just kind of take people out of the equation. But what he told me, this guy, he said that he actually had to increase his work task now, because someone have to put up the sensors, someone have to calibrate them, someone have to react when there are alarms on them, someone have to see if the data looks correct, and all these things. So actually, the more technology they put into this building, the more work he has to do, even though it's supposed to actually make it more automated and less work for him. So I think that's a very relevant perspective to remember when starting to maybe considering putting more technology into buildings. Is that actually doing what we want it to do? Or could we just find another point where it would meet our needs and not just make extra work? Next example from a daycare institution. This one is from a project called Courtesy, which is concerned with energy performance and performance gap. These buildings are used for daycare institutions, and they are pretty old, and then it was decided in the municipality to retrofit them. And the renovation included ventilation and lighting. And the overall purpose was to increase the energy performance, to to get some energy savings and some more energy efficiency. The smart solution they chose in these buildings were automated control of the lighting. So it's controlled by presence and of the outside light level. And that's usually a very nice smart solution, but in this specific context, it wasn't as smart as it was supposed to be, because the lighting was not sufficient for being flexible in the way they were using the rooms in this daycare institution. For instance, they would like to be able to dim the light for reading sessions or for making cinema experience. And also, and this was the most important one, the kids who attend this daycare institution, they have to nap. And it's not very, the solution didn't really work out for those kids having to be completely still on in their beds, trying not to put the light on. So instead, to actually make it a smart solution was to give these daycare institutions dimmers, so they can make these different atmospheres that are very good for the pedagogical work, and then making it possible to overrule the system and entirely shut down the light when the kids were supposed to nap. Also, another interesting issue with this project was that it didn't seem like the employees in the daycare institutions fully had the understanding of how this technology actually worked. For instance, they didn't quite believe that it should be so energy efficient as it was stated, because it would be on at some point where they would never have turned on the lights themselves. So it seems like there needed some explanation of how this technology works, and that it tries to even the lux level in the entire room and all these things. So the thing about involving the users and actually make them understand what the technology is giving and how they're supposed to use it. Yes, then the final one, that's the one that's a bit different. That's a quite big project we are working on in UN City. It's a quite new building in Copenhagen, housing the United Nations organizations in Denmark. And this project is to try to move further in this progress, to try to see if we can close that performance gap. Because even with the most intelligent buildings we have and the best constructed ones, we still see the same challenges that I mentioned before with performance gap and rebound effect. So they decided to try to see what can we do with this type of building instead of just copy pasting the solution and then it's actually not working the way we like. So this project is about mapping the user behavior in smart buildings and see what is actually going on when you put people into a building so sophisticated as this specific one. It's quite remarkable on sustainability and smart functions. It has solar panels, automatic solar shading, seawater cooling, collection of rainwater, and automated control on room level. It's designed to use at least 55% less energy than similar buildings, and it has been Platinum LEED certified and also has the European Commission's Green Building Award. So this is some of the best buildings we can make, and still we experience these challenges. We see a higher energy consumption than expected. We see a minor difference between peak and standby consumption. Then there's an uncertainty on whether installations operate as expected. And there are temperature differences between floors, which is some part of due to the design of the atrium. Then there's a perceived low air quality. And finally, which is also a very general thing we experience, there's an extensive amount of unutilized data. Because when you have these sensors on everything basically, and you have access to so much data, but what to do with it and how to use it, and that's still kind of unclear. So our preliminary conclusions in this building is that, first of all, regarding the operation, there are some unclear division of responsibilities. Who is supposed to do what? When you have multiple organizations and someone owns the building, someone rents, and all these different dynamics will mean something to this division of responsibilities. Who's supposed to do what? You have the energy consumption and indoor environment. It's not specified work task. You don't have someone's contract where it's specified this is something you need to work with. And these preliminary conclusions are something we see in other similar buildings as well. Then we have this thing about the energy management. It relies very heavily on the individual. Is it someone who by chance have an education that makes them able to manage it? Maybe they have a personal interest in it, and maybe they have a competence from other things they've done before. But it's very random, so to speak, and it makes it very vulnerable if this person change job or the structure changes or something like that. There's a lack of general procedures about this. And then regarding the end users, we see that user expectations to the building, they are not aligned with reality, and that users lack knowledge of their impact on the building. And it's something general with end users as well. This thing of measured values and the human experience. Even though you can prove with objective data that this indoor environment in this building is perfect, that's just not gonna cut it if people have a different experience. So it's something about explaining what can you expect from a building like this, and what is just not possible. And also the thing Kasper talked about with solar shading, what happens when you choose to take the solar shading away? How does your behavior in that moment affect the entire building and the energy consumption? So I think those are the biggest issues we see here and in general in similar buildings. So the overall conclusion from this one is that if we want to achieve this potential, because the potential is there, we have wonderful technologies and we can make great buildings, but if we really want to achieve that potential, we need to be better to integrate those elements of the behavior, the building, and the technology. A technology is not smart just because it's smart. It's only smart if it actually is fitted for the behavior in that building, in that context. And you can't just copy paste solutions. You have to evaluate that every time to make it smart in practice. Yes, and that was it for me actually. So I think I will send it to Vitaliy. Thank you.
Dear colleagues, it's a big honor for me to present here. So I would like to start. I would like to start my presentation. So actually, we raise here a very interesting topic about operating of smart buildings and how usually people operate it and what they do expect after operating a smart building. And my colleagues also answered partly that sometimes making your building very complicated, or if you're installing so many smart solutions there, you can overestimate the capabilities of the operating people and people working with the maintenance of the specific building. And that's why I decided to call the topic of my presentation Smart Buildings in a Smart City. Because sure, like Babette mentioned, we are aware now about all the modern and available technologies that let people operate their buildings in the most efficient way, and we can really track and measure all the consumption levels that we need. But how it will result in overall consumption level, for example, on a city perspective? If we are speaking about a big city, maybe we can go a bit lower to the municipality or micro district level. But nevertheless, this is the question that I also want to discuss in my presentation. We need to let's speak about the definition of energy management system, and let's speak about the complex solution of technical administrative measures that aims to reduce the energy consumption of municipal building or any other type of public building or private one. It doesn't matter. The proper functioning energy management system helps people to analyze and monitor the information about energy consumption and help later the city prepare the correct city energy action development plan and conduct proper planning of the financing resources that they want to invest in the energy efficiency. Sure, when we are speaking about a single smart building, we are speaking about people that are living inside it. Sometimes, if it's a public building, like the UN city that Babette presented in her speech, here we are speaking about certain people that are going to the work every day, more than 1,000 people who have their own pattern of behavior, and we can actually measure and understand their way of behavior because they are in the public building. So all the activities are more or less public. But if we are speaking about the residential sector, sometimes it is hard to monitor and evaluate and even model behavior of the people that are living in a common residential buildings. This is also a way how cities should plan their energy activities, and this is the solution. The solution of it is implementation of energy management system. We also need to understand that constant level of constant control of consumed energy resources for each building in the city is also very important for the city administration and for the overall planning of the energy resources consumption level in the city. We can also think about the smart buildings that are integrated in the city, and they also are connected to a certain smart grid and giving a lot of data to an analytical center. But the main question is who will be the owner and operator of this analytical data center, and who will make the conclusions based on the data that they will receive? The simple answer is the energy manager. Yes, sure, energy manager is a specialist who have the certain capabilities and knowledge to provide such kind of assistance, but should it be energy manager for the specific building or for the region or for the city? This is a very tricky question, and at the moment most of the cities and the vast cities in the world are trying to resolve it, integrating energy manager in a common maintenance practice for different types of the buildings. And why it is important and what it will give us. Sure, we are speaking a lot about energy efficiency and reduction in certain energy consumption, but the only way to confirm the energy efficiency and the level of the reduction in consumption is to measure it. This is the only way how we can prove and how we can confirm the efficiency of the operation that we implemented in place. And that's how we can evaluate and make the certain benchmarking of the technologies that we implemented and all our smart solutions. And here we can even track the size and the possibilities of the smart solutions, and even understand maybe their oversize for the specific building. So what I want to say that we need to implement a proper functioning monitoring system when we are speaking about smart buildings integrated in a smart city. Proper functioning monitoring system will allow us to track the performance of the buildings for that were newly constructed or retrofitted or just operated in the region. And we also need to understand that there are certain steps, certain tasks that need to be resolved before we can say that proper monitoring system is in place. Sure, we need to have all the energy meters and the other relevant measurement equipment installed and ready to be connected to some remote data connection. On the other hand, we need to have energy manager in place who will be really dedicated and motivated to conduct proper energy analysis and calculate the energy efficiency of the specific buildings. Sure, we are not speaking about just self-motivation of such kind of energy manager. This person should be trained and should have a certain guidance with certain methodological steps, like step number 1, number 2, number 3, how he or she need to track the energy consumption. What does it mean, good or bad energy consumption? What are the deviations? How they can appear? What are the seasonal and other factors that are making impact on all of these figures? This is the real role of the energy manager. Here we can see the schematic view of the remote data control system that is actually similar all over across the world. So you have a certain server that collects on a cloud basis all the data. You have certain equipment that collects data on the ground from the energy resources, and some calculators or transmitters that really calculates the the consumption rate of specific energy resource. That's it. And sure, it could be done on the internet base with the web platform with an attractive interface. But again, we can raise a question: who will be the operator of such kind of a software? Yes, we are speaking now about giving a better role, a bigger role for the people who are operating on the ground, all this smart equipment that is installed in the building. And here we can say some developed algorithm of action for energy manager. And, this person should make some analysis of current structure, existing city administrative structure in terms of energy use, or maybe building structure in terms of energy use, if we are speaking about a specific building. Then we need to understand which actions we can take in a midterm and long-term perspective. Which kind of actions could give us immediate result, and we can call them even low cost or no cost measures, and which kind of actions will give us result only in a long-term perspective, but we should invest in them now, otherwise we will lose our capacity and efficiency at the moment. We don't need to forget that all investments that we will do today will be cheaper for several inflations compared to the investment that will be done in 2 or 3 years. So that means that investing in energy efficiency now is much cheaper and smarter than wait until our system will be broken and will be ready for a real capital retrofit. Sure, we need to develop a certain methodology for sustainable energy action plans or sustainable city energy action plans if we are speaking about the city scale, where we need to include the smart buildings integration and smart perspective of the buildings. But nevertheless, we need to understand that without proper trained people on the ground, we could not make it happen. So we don't need to forget to integrate the trainers courses for energy managers, educate them from the administrative perspective, from the municipality level, from the departments level, sure, from the buildings level as well. All the buildings that consumes energy are sure have their own energy management system in place. But this is the question, how they can measure and evaluate the efficiency of it. On this slide, we can see some schematic view for a common, here is a hospital, for a common hospital type building integrated in a smart energy performance measuring process in a city scale. So you can see that all levels of the city administration, starting from mayor or deputy mayor, all the departments and city or municipal responsible people have access to the certain database that gives you this data. Sure, Babette mentioned very correct that sometimes we are collecting more data than we can accept and that we can absorb and evaluate. This is also an important question, and we need to understand that we should have and should prepare a certain methodology of the analysis of the data. So not all the data that will be collected should be presented for all members of the society or for this energy management system. For example, deputy mayor should have only the overall big figures. Some departments should have an access for some detailed figures on specific levels of consumption per days, for example. But people who are responsible for the maintenance and the energy consumption level in specific buildings should have immediate access for the all available data that are collected for this building. So, in the conclusion of my presentation, I also want to mention several practical lessons learned that I also made during my professional career. So sometimes if we are speaking about implementation of a smart buildings in a smart city, there are certain absence of understanding of role of energy managers in departments or in the communal service companies, and there is an absence of this position. Sometimes it should be budgetary financed, and for big cities it is always a problem how we can do it. No motivation or interest to reduce energy consumption from end users, especially if we are speaking about municipal buildings. We need to understand that the specific director of the school or hospital sometimes is not interested to have access to the energy efficiency, because they will just be cut it in financing. There are some other difficulties that people can make on the work, that absence of unified automatic system that gather the data for monitoring, difficulties to work with energy supply companies, which sometimes try to hide some real figures of consumption, and for sure the lack of awareness and understanding of situation in city administration level. All of these barriers should be overcome by the activities, by the webinars like we are doing today, by the deeper involvement of the city and regional administration to the dialogue of the integration of smart cities of smart buildings in the smart cities. And that's all from my side. Let's shift to the discussion. Thank you. I'm giving the floor to Valeria.
Perfect. So here we have one question for our panelists. So, are technical solutions in one country scalable to other countries? Thank you very much for your answers.
Thank you, Valeria. I can take that one. I think very much what I talked about as well was the assumptions in the design phase, which is when you're doing it scalable for other countries, it's very important to be aware what your assumptions should be depending on your building type and yeah, basically that is. So I would say with the technical solutions we see today, we can make it scalable to every single country. And as far as I see it, this is already something that is being done. We just need to be more aware of the assumptions we make in the design phase.
Thank you very much, Kasper, for your answer. Do any other of the panelists have any interventions on this issue?
Yes, I would like to add something. I think that Kasper is absolutely right that of course we can scale, but I think it's important that we buy into this premise of that every context is different. So if we just got used to doing that as a standard of always assessing that specific building and the behavior in it and then fitting the technology to it, then it would be absolutely no issue to scale worldwide. I just think we need to get past that copy-paste thinking that I think we might have some issues with right now. But yeah.
Thank you very much for your input, Babette. It's surely very interesting to hear all your points of view. This panel discussion also covers another question. In your opinion, how important is ambition and goal setting when choosing the technical solution? If Kasper or Vitaliy or Babette want to answer, that would be really interesting to hear your opinion about it.
I would like to start, if you don't mind. So it's actually a very interesting question because like Kasper mentioned in the start of his presentation, you don't need to oversize the complexity of the technical solution that you implement in the specific building in accordance to the capacity of the local maintenance people. So what I'm trying to say that if you are trying to implement a smart building solution for an ordinary small school or kinder care center who are sometimes not prepared for a real advanced technology, you just don't need to do it. So you can put an ambitious target, but don't oversize it. But on a vice versa way, example with the UN city, this is the ambitious building, well-known one. And here you can put the most ambitious target that you can have and even overcome it. Thank you.
Thank you, Vitaliy. Kasper, Babette, would you like to jump in as well?
I'd like to add a bit as well. I think it's very important to see it as a kind of trust. So both as an operating manager and as a user, it's very important that you have the trust to the technology. So as well how advanced the technology put in the building should be is very depending on if it's easy to use and you see it as trustable and you can kind of understand why the technology is behaving as it is.
If I may add something again to this, I think it's also the thing about ambition, that you don't have to put technology in a building for the sake of technology. I think it would be more useful for everyone if you take one technology that actually makes sense for the behavior, rather than putting in 5 that doesn't really fit with how people actually use the building. So maybe it would be okay to scale down that ambition level of how much technology can we put in, and try to be more selective in the way we use it, so we get quality instead of quantity. So yeah.
Thank you very much for your input. It's really interesting to hear your opinions. And one last question for the panel discussion. So to all of the panelists, how can we simplify the understanding of user behavior to be applicable for smart buildings? Thank you.
Well, I think I'd like to start with this one. Well, I think now I have really tried to highlight the importance of user behavior we all have in this one. I think that's why we're doing this webinar. But still, I don't want it to be more complex than it is. Just actually taking some time to assess what kind of users are in this building and what would make sense for them. I think just doing that would make a huge difference compared to the way it's often done in practice right now. So I don't think I don't want to kind of scare people off, and you have to do a really extensive anthropological investigation every time. Of course you can do that, but I think it's just think who are going to use this and how are they going to use it and why are they in the building. And I think just keeping that in mind will make it more easy to actually hit the spot with this when you choose technology and try to design buildings that make sense for people.
Any other of the panelists would like to jump in, or we can start with the open Q&A session for the participants? Good, so we can start now with the Q&A session. The first question we have here, and please to all the participants, send your questions so that we can present them to our panelists. So the first one here is for Kasper. You just mentioned operation trust to technology. How can users and managers increase their trust? Is it larger the role of users or of technology? Thank you.
Thank you, Valeria. I think it has a lot to do with how the technology behaves. I normally use the example with the solar shading, where when the sun is up and shining into the room, then the solar shading is going down, and thereby not letting the sun or the heat into the room. That's fine so far, but then if it reacts too fast or too slow, then maybe it's gonna go down as well if it's cloudy, or maybe even starts raining or something like that, if the sun has been there just briefly before. It's very important that we could see the logic in how the technology behaves. Another thing is the radiator. If you feel that your room is overheated, and at the same point you feel on the radiator and it's warm, there is as well a disbelief in that the technology is doing the best for you, and thereby you can maybe want to overrule the optimization, and that's when it could go bad. So that was just a couple of examples where you can lose trust. What is more difficult is if you believe that your ventilation is sufficient. Sometimes you can feel that you don't have as much fresh air in the room as you would like. But then if you do the measurements and you compare it to the typical requirements for sufficient fresh air to the room, maybe it is sufficient, but it can be related to other things like overheating or maybe a bad smell from food or something like that. It's something about whether the technology behaves as you would expect, but it could also be that the user might not have the understanding or a bit of maybe education about what you can expect and how the technologies in the building is performing for you as the user.
Thank you very much, Kasper, for your detailed answer. Here we have another question from one of the attendees. To what degree is a ECT infrastructure a prerequisite for effective energy management system? Can it be realistically done with manual readings of energy meters, thereafter input into a central tool? I ask for those cities wishing to implement an energy management system, but not yet able to fully invest in adequate infrastructure. So if any of the panelists would like to answer to this question.
Yes, thank you. I would like to answer. Yes, you're absolutely right, colleagues, that sometimes cities are not ready to start the smart measurement system at once. And sure, the software that is supposed to be implemented in the city should have a possibility for the manual data input. And manual data input is also fine. And sometimes you don't need the real online figures to make the proper analytics. You just need to understand the changes of consumption according to some typical scenarios of your region, for example, climatic change or daytime change or working, not working hours of the building and so on. So these are the figures which are used for the operation of the energy manager. So the simple answer is yes, you can use the manual data collection for the cities. And another topic that we can also raise here is the incentives that city could use for the energy supply companies who should be obliged on a mandatory basis to install the smart meters in the buildings. Otherwise, they just need to give online or proper data of consumption at any time according to the energy supply contract which a specific building has, for example, school, hospital, or a residential one. This is also a question that usually arises in the region, and in some of the countries we have good results of pushing energy supply companies for massive integration of smart meters because of this issue. Thank you.
Thank you very much, Vitaliy. It was really interesting to hear your answer. Do any other of the panelists would like to give their input as well, or shall we proceed with the next question? It seems that there is a problem in retaining the appropriate design options, which seems to increase the risk of negative behavior impacts in the operational phase. For example, high performance glazing types versus solar shades, level of automation in interaction with space occupancy requirements, etc. Would any of you like to comment on this?
Yes. Yeah, I think that's definitely one of the points we're trying to make today, that we need to get the user behavior into all the phases of a building. In order to have a proper operation, you have to do the right things in the design phase. So definitely, we need to be able to actually integrate all those parts instead, and also again changing it, instead of making a building and then letting people move into it and then think that they have a wrong behavior. Don't you think that we should be able to make technology that fit the behavior, the actual behavior of people? I think if we can't do that, we didn't really make technology that actually benefits our lives and worlds. So yeah, I think that's a good point, and I think we need to improve our work in the design phase to actually have the operation that we need, so we can close that performance gap that we keep experiencing.
Great, thank you very much, Babette. Here we have another question. Is there any experience of so-called nudging strategies or gaming methods? Who is the most efficient, basically, to adapt behavior? So probably here if any one of you could just explain a good case of nudging strategies for either, I think, a smart building or overall a nudging strategy. Thank you.
Yes, again, I think I have to highlight this point of context, because what works efficiently in one building will not necessarily work in the other. So again, that's why if you want to do a nudging campaign or a visualization of data or whatever it could be you're interested in, you have to really evaluate the context you're going to do it in. Is it an office building? Is it a daycare institution? Is it whatever it could be? And then make it fit for them, because it can be so different what people will respond to. If you're talking about data visualization, for instance, I usually think that there are several motivators you can work within. It can be something with the financial matters, how much does it cost? It can be something with comfort, indoor climate, and it can be something with the sustainability. And every person will not respond equal within the same subject. So you need to evaluate. So what kind of audience do I have now, and which one will make sense for them to communicate through? And then find out the platforms. If it's an office building, where can you see that people use? How can you see that people use it? Do they often stand around the coffee machine? Maybe that would be the contact window you would have to do a nudging campaign. Or is it in the canteen, if there's a canteen in the building, or how do people use it? Really evaluate that and use that to make a campaign that actually makes sense. And yeah, maybe it worked in one building and it didn't in another. But a general thing we can see is that you will have a very high impact when you do it, and then it's the long-term effects that are difficult. So it's when you start a nudging campaign or visualization campaign, already think about long-term effects from the beginning and see if you can kind of relaunch your campaign from time to time. Yeah, it could also be if it's in a building where people live. Maybe you could have ambassadors in that building, or when a new person moves into the building, it's part of the move-in ritual that they get an explanation of how to use the thermostats in a way that makes sense for this building, or whatever it could be. So yeah, just get creative and think about context. That's the most important thing.
Thank you, Babette.
I'd like to add a little bit to that, Valeria.
Yes, of course. Go ahead.
Because we hear more and more often that why can't we just take away the option for the user to go in and manually overtake the optimization? And this is not nudging at all, but I think it's worth discussing if there could be maybe a bit less of interference from the occupant, so that they can control what is maybe possible for them to understand in terms of the building, and then let the optimization do what it does best. But then it's very important that the building has been designed for the correct usage, and that it can actually gain that necessary trust, that it can do what is necessary to bring in a good indoor environment.
Thank you, Kasper. Vitaliy, would you like to add your opinion as well?
Actually, I can say that my colleagues answered pretty much, and I can just agree with the conclusions that they make. And sure, I can say that proper solutions should be only implemented in proper places and where people are really ready to have them. That's it. I think we can proceed with the other questions to not take more time for this one. Thank you.
Perfect. Thank you for your answers. This is a question for Babette. How can we see or understand if a technology fits the behavior? Thank you.
I think it makes sense to go back to the examples I brought, because it's very obvious when they don't fit, when you have kids that cannot nap because the lighting is controlled by movement. That's what I mean when I talk about solutions that actually fit. So if someone would have evaluated the behavior in that daycare institution before, you would have been able from the beginning to find the solution that fit, because you would know, of course, they have to be able to turn off the lights in order for the kids to sleep. So that's what I mean when I'm talking about solutions that fit the behavior. And again, with the example from the university, it's not that difficult. Actually, it's, you know, if you just go into that building and see how they use it, and you will see all these students with working in groups, and you know, the noise level. There's a ping pong table just outside with a lot of noise. Just the design of the building makes it uncomfortable to work there in the way they're supposed to work, and then you can see why they would never want to book a place there. So you would not have come up with that solution, or non-solution, we should call it. So that's what I mean when I say that we need to try to actually find some solutions that fit, because we have the technology, but not all technologies make sense in all contexts. It's about finding out how does it work in this specific building with these specific people. I hope that was answered enough.
Thank you very much, Babette. And here there's another question, and in the meanwhile, if the other attendees want to send their questions, they're very welcome to do that. So this is a question for any one of the panelists. At policy level, how can decision makers insert these findings in their decisions? Thank you.
Let me start to answer to this question. Actually, if we're speaking from the city perspective or regional perspective, it is on one hand it is easy, and on the other hand it's complicated. Easy means that sure there is a certain legal framework that makes the certain guidelines how cities should plan their energy efficient actions. So usually it's an energy efficient plan, or a city energy action plan, or such kind of document. There, for sure, there are certain positions where you can mention certain requirements for energy efficiency, for new construction, for retrofits, and so on. On the other hand, this document also have a budgetary page where city determines the certain expenses for this or that perspective, and the part of energy management should exist there somehow with the position of energy manager, or with a certain mechanism which will help city to track and verify the results in the end. So the most important factor is not only to include in the legislation the requirement to measure the consumption or to follow certain requirements, but also to describe in details the verification mechanism, the methodology for the performance tracking, and so on, to let people work and analyze it in a continuous way. Thank you.
Thank you very much. Do the other panelists want to add anything to this question?
I think I'd like to add a little bit, Valeria. In Denmark, we got some examples from municipalities where they are retrofitting quite a lot of public schools, and there they are often bundling their monies to retrofit the school. But what they often forget there is that if they might have, which they often have, focus on energy savings, they miss that this could actually be really bad for the indoor environment. So it's not lack of competence from the decision makers. It's more that they maybe forget that if they are changing the windows to save energy, that might be a bad decision for the thermal indoor environment. There they maybe have to bundle their technology technologies as well. So, for instance, in Denmark, it's quite common in public schools that they are being served with natural ventilation, and maybe that's not very sufficient. So, if they are already retrofitting the school, it could be a good idea to maybe, if they want to change the windows, then as well to put in some better ventilation. And I think what we need to do in that matter is to maybe highlight that the indoor environment is not unchanged when they are making energy efficiency decisions. It is very often either improved or it becomes worse than it was before. And with that knowledge, they can maybe be better at taking the right decision in the beginning of that phase. Thanks.
Perfect. So thank you very much for the detailed responses to the questions. So finally, we come to the end of the webinar. I would like to say thank you to the panelists for their informative and interesting presentations, and of course to the audience for their active participation. The presentations will be beneficial for all stakeholders involved in energy efficiency. Thank you for your attention and wish you a good day or night from a sunny and warm Copenhagen.